Right, we have a aqueous solution of cobalt chloride, which is pink, and a clear solution of sodium hydroxide. The word equation and the balanced equation for the reactants are shown. The full ionic equation is shown here, and it shows all of the ions present in the solution, followed by the net ionic equation for the reactants here. On mixing, when the cobalt and the hydroxide ions meet, they will form a precipitate. This precipitate will be a blue color. The cobalt hydroxide blue precipitate will be shown in the net ionic equation, and the spectator ions, sodium and chloride ions, will be removed. The solubility table here shows what ions will precipitate out of the solution when they come in contact with each other. For example, a solution of sodium chloride contains the sodium ion, and the sodium and the alkali metal ions will never precipitate out and always exist as aqueous solutions, whereas hydroxide and most compounds with hydroxide will precipitate out. Now, using the solubility rules, we can explain what is going on at the molecular level in these equations. Looking at the aqueous cobalt chloride solution, we can see that the cobalt and the chloride exist as separate ions in a ratio of 1 cobalt ion to 2 chloride ions. Looking at the aqueous sodium hydroxide solution at the molecular level shows that there's a 1-to-1 ratio of sodium ions to hydroxide ions, and the solution is colorless. However, on mixing, both solutions come into contact with each other, and the ions that were in the separate solutions are now mixed together. And in this scenario, we have the cobalt and the sodium and the chloride and hydroxide ions moving around freely. Now, when the cobalt and the hydroxide ions will meet, they will form an insoluble precipitate, and consulting the solubility table shown before, we will see that the cobalt and hydroxide will form cobalt hydroxide solid, as you can see here. And then they will move to the bottom because the solid is obviously denser, and they will congregate to the bottom of the solution. Now, the complete ionic equation is shown here, showing everything, including the aqueous dissolved ions and the ions which precipitated out. The unreacted ions, aqueous ions, spectator ions, can be omitted, leaving the precipitate, and this can be shown in the net ionic equation where we've cancelled the spectator ions, and it's shown here. So cobalt plus hydroxide goes to cobalt hydroxide solid.